you solve paper 3 spring 2024. The duration of the paper is 1 hour 50 minutes. So let's get started. Question number 1. Find the quotient and the remainder when this expression is divided by x squared plus 5. Question number 1. We have to do long division. The dividend is x squared 3x cubed 9x squared minus 12x plus 27, and the divisor is x squared plus 5. First of all, we have to see whether all the terms of the dividend and of the divisor are in descending powers. If it is so, then start the process. The first step is divide the first term of the dividend by the first term of the divisor. Whatsoever the answer, that would be your first term of the quotient. So x squared over here. Now multiply this x squared with the two terms of the divisor. So as a result, we get x4 and then 5x squared. So we are supposed to write x squared beneath x squared, not over here because it is x cubed. Now after having done that, we are supposed to do subtraction. That is, we are going to change the signs of the lower terms. It was plus, it's now it's become minus. So as a result, the first terms will be cancelled out. And when we write down this next line, we always follow the same procedure. What is that? We always write down the terms in descending powers. So 3x cubed plus 4x squared minus 12x plus 27. And then again the same process. First term divided by the first term of the divisor. As a result, we have 3x. That would be the next term of the quotient. Now multiply minus 3x with the divisor. So it would be 3x cubed with a negative and minus 15x. 15x again, like terms. Now we are supposed to change the signs. Let me change the color. Okay. Now plus and plus, first terms cancel out. So now again we are going to use the same procedure, that is copy the terms in descending powers. So 4x squared plus 3x plus 27. Now the rest of the process is the same. 4x squared divided by the first term of the divisor, we have 4. That would be the next term of the quotient. So now we have 4x squared plus 20. Then we are supposed to change the signs again. Let me change the color for you. Now change the signs. First term always cancel out. Now 3x plus 7. Now this is our remainder, and this is our quotient. We have to find out the quotient and remainder, so we will write that the quotient is x squared minus 3x plus 4, and the remainder is 3x plus 7. That's it. Question number 2. Find the coefficient of x squared in the expansion of 2x minus 5 root 4 minus x. We have to find the coefficient of x squared from 2x minus 5. Its power is 1, so it means this is not going to be simplified. The other one is 4 minus x root means 1 over 2. It means we are going to simplify this. We are going to expand this, and then afterwards we will find the coefficient of x squared as a product of these two factors. Let's work on this. But before that, we should know the formula for the binomial expansion. The formula is 1 plus x raised to the power n, 1 plus nx, n minus 1 x square over 2 factorial, and so on. As we need to go to x squared, so let's expand the first 3 terms. But before we apply this formula, if you notice that the first term is not 1, so we have to make first term 1. So I will take 4 common, 1 minus x over 4, and the whole power is 1 over 2. When you simplify this, you will get 2, 1 minus x over 4 power 1 over 2. So it means you are going to expand this thing. So it means 4 minus x power root 1 over 2 means 2 times of this expansion. We are going to expand this. Now here n is 1 over 2, x is minus x over 4 along with the sign. So 1 plus n, and then we have x, which is x over 4, plus n into n minus 1. 1 minus 1 over 2 is minus 1 over 2, x square minus x over 4 square divided by, it means 1 over 2, 2 factorial. Well, let's simplify this. So we have 2, 1 minus x over 8 minus, that will be x square over 128. So after simplification, we have 2 minus x over 4 minus x square over 64. This is the answer for this factor, 4 minus x 1 over 2, using the binomial expansion. So now let's find the coefficient of x square as a product of these two factors. So let me write down the question again for you. The question was 2x minus 5 and 4 minus x root. So 2x minus 5 as it is. And here we have 2 minus x over 4 minus x square over 64. Now we have to find coefficient of x square only. So we will multiply this 2x with x and this constant term with x square. We are not interested in rest of the terms. So let's multiply. So 2x multiplied by x over 4, that would be x over 2 with a negative sign. And then we have minus minus plus 5x square over 64. So we have 62 over 64. Let's take the LCM. So we have 64 and we have 32 with a negative plus 5. So we have x square minus 27 over 64. So coefficient of x square equals to minus 21 over 64. Now, in the B part, we have to find the set of values for which the expansion in part A is valid. Now we know that if we have a binomial expansion, 1 plus x raised to the power n, whatever the formula, the range for values of x is x modulus less than 1. Now here we have expanded 1 minus x over 4 raised to the power 1 over 2. So here the range would be x over 4 modulus less than 1. So the x range would be less than 4. Or you can say minus 4 to 4. This is the range of values of x. Question number 3. It is given that z is equals to minus root 3 plus iota, complex number in Cartesian form. Express z square in the polar form or in exponential form. It means we have to find the angle as well as the magnitude of z square. So we have two options. So first one is that we find z square in Cartesian form and then find its angle, or we can convert z in the polar form and then find its square using de Moivre's theorem. I'm going to use the second option. I'm going to multiply z with z square, then proceed further. So in question number 3, the formula, the z which is given in Cartesian form is root 3 plus iota. I'm going to convert this in polar form or modulus argument form, or you can say exponential form. First of all, find its magnitude. So that would be minus root 3 square, 3. 1 square is 1. Take its under root, so 2 units. So this is the length of complex number. Now we have to find its angle. In order to find the angle, we have to find the quadrant. It is negative, and y is positive. It is somewhere over here. So this is root 3, this is 1. As we are interested in the basic angle, so we are considering it positive. So let's find the basic angle, 1 over root 3. So the basic angle is pi over 6. The basic angle is pi over 6, as it is in second quadrant. So the argument would be pi minus pi over 6. That would be 5 pi over 6. So Our argument of c is pi minus pi over 6, which is 5 pi over 6. Now we have the argument as well as the length. So complex number z minus root 3 plus iota in polar form equals to, or in modular, or in exponential form. We are writing in exponential form as it is required in the exponential form as well. It is r e iota theta. R is 2, so it means iota 5 pi over 6. So this is our required complex number. This is our given complex number in polar form. Now our required complex number is z square. So z square means squaring z, e iota 5 pi over 6 square. The 2 square is 4, no problem. E iota 5 pi over 6, that will become 5 pi over 6 into 2, 5 pi over 3. 5 pi over 3. But the problem is, this is not inside the range. We know that the argument always falls in between minus pi and pi, so we have to readjust it. So if it is beyond the range, beyond the range means if it is greater than pi, we will subtract 2 pi. If it is less than minus pi, we will add 2 pi. So here is it is greater than pi, so we will subtract 2 from it. So we have minus pi over 3. So it means the argument is minus pi over 3. So it means z squared is actually 4e minus pi over 3. Question number 3, be apart the complex number omega is such that z square omega, that is z square into omega, is real. And z square over omega whole modulus, that is the magnitudes division, is equals to 12. So with the help of these two information, we have to find the complex number omega. Find the two possible values of omega, giving your answer in the form of, again, exponential form, where r is greater than 0, length is positive, and angle is in between this value, which is usually the range for any argument in complex number format. We are given with complex number omega such that its length is capital R and its angle is alpha. Or you can say in polar form it would be cos of alpha iota sine of alpha. Okay, the information given is that z square w is real. So let's find z square w. First of all, we know what is z square. We have just calculated in the previous part. It is 4 e minus iota pi over 3, and omega is r 4 iota alpha. Let's multiply magnitudes with magnitudes, and angle will be added. So 4 iota, so when we add the angles, so we have iota minus pi over 3 plus alpha. This is our argument for the product, and you can write in polar form like 4r cos of minus pi over 3 plus alpha plus iota sine minus pi over 3 plus alpha. Okay, it is given in the question that it is real only. This product is real only. This means we don't have imaginary part. We don't have this thing. This thing is 0. Imaginary part is 0. So what we are going to do, we are going to equate it to 0. Solve this. So imaginary part minus pi over 3 plus alpha is equals to 0. And we know that alpha, by definition, all the arguments are in between this range, minus pi to pi. So is this argument would be. So let's solve trigonometric equation. We know whenever sine or cos is equal to 0, we write down the answer directly. So minus pi over 3 plus alpha is equals to sine theta is equal to 0 at 0, pi and 2 pi, and subtract 2 pi from here. So we have 0, which is already written. So subtract 2 pi from here, so we have minus pi. So these are the total possible values. So let's find out the values of alpha minus pi plus pi over 3. That would be 1 minus 1 over 3. 2 pi over 3 with a negative. Is it inside the range? Yes. 0 plus pi over 3 is pi over 3. Then pi plus pi over 3, that would be 4 pi over 3. 2 pi, yeah, okay. Rest of the angles are not inside the range. So these are the two arguments possible for this z squared w condition. So with this omega, the arguments are pi over 3 and minus 2 pi over 3. Now we have the arguments of omega. Let's find out its length, magnitude. For magnitude, we have another information. That the information is that z square omega whole modulus is equals to 12. Now we know the definition of complex number. Z square modulus or omega modulus is equals to 12. We have the z square modulus. It was 4. So 4 is equals to 12 omega modulus. So omega modulus or omega length is equals to 1 over 3. Now we have the length. Now we have, and we also have the arguments. Arguments are pi over 3 and minus 2 pi over 3. So let's write down the answers for omega. So omega, first answer is 1 over 3 e iota 2 pi over 3. Another one is 1 over 3 e iota pi over 3. So these are 24. Question number 4. The positive integers p and q are such that natural log of p over q equals to a, first information or first equation you may say, and log q square p product is equals to p. So we have two equations we are going to solve and simultaneously find the values of log p power 7 q product. Question number 4. The first information is that log of natural log of p over q is equals to a. So we can write this as natural log p minus natural log q equals to a. This is the first equation. So the second equation is natural log of q square p is equals to b. So here we have product, so it will be added using the logs laws, is equals to b. Take this 2 as coefficient, so 2 ln of q plus ln of p is equals to b. Now we have ln p, ln q, ln q, ln p. So let's replace this with some other alphabets for convenience. This is not compulsory action. So let's suppose that ln p is equals to, let's say another variable, let's say x, and ln q equals to y. So by substituting these values in equation 1 and 2, we will have another equations in the form of variable x and y. Then we substitute it back to find the values of the required expression. So as a result, the equation 1 would be x minus y equals to a, and the second equation would be x plus 2y equals to b. The first equation would be x minus y is equals to a, and the second one is x plus 2y is equals to b. Now let's solve them simultaneously. X cancel out, so we have minus 3y equals to a minus b, or y equals to b minus a over 3. This is the value of y. And x would be, you can solve it right from the scratch, or you can substitute the value. We can solve these equations again. That we multiply the first equation with 2. 2x minus 2y is equals to 2a, and x plus 2y is equals to b. So as a result, these variables will be cancelled out. 3x is equals to 2a plus b. So x equals to 2a plus b equals to 3. We can also substitute this value of y in this expression to find the value of x. Okay, now we have ln x and ln we have x and y values. It means we have the value of ln b. Ln b is 2a plus b over 3, and ln q equals to b minus a over 3. Okay, what do we have to find out? We have to find out, change the color, we have to find the value of log of p7q. That is, we have to find log p7 plus log of q, 7 log of p, ln q. Let's substitute the values which we have just calculated. 2a plus b over 3, ln q is b minus a over 3. So the denominator is the same, so it's easy to take the LCM. So 7 to the 14a plus 7b plus b minus a. So we have 14 minus 1, it is 13a. 13a plus 8b over 3. This is the answer for log p7q. This is our required answer. Question number 5. On a sketch of an arcane diagram, shade the region whose points represents a complex number z satisfying the inequalities. First inequality z minus 4 minus 2 iota less than equals 3. In this inequality, on the left hand side we have z, on the right hand side we have just a constant. It means this is going to be a circle. And the second condition is c modulus greater than equals to 10 minus c. In this we have two moduluses and we have two variables. This is going to be a straight line, and it means one is straight line, other one is circle. Let's draw them together. The first thing is the circle. We know that z minus 4 minus 2 iota less than equals to 3. We can take minus common. After taking minus common, whatsoever is inside the bracket, this is the center of the circle. So the center of the circle is 4 plus 2 iota, or you can say the center is 4 and 2, and this is going to be the radius. Radius of that circle would be 3. It means we are supposed to draw a circle and the center would be 4, 2, and all the points inside that circle is your required locus. This is condition number 1. Now the second condition is z modulus greater than equals to 10 minus c modulus. It means we are going to draw a perpendicular bisector of the point. From here it is obvious that the point is 0, 0, and the other point is 10, 0. We are supposed to draw a perpendicular bisector of these 2 points. This point is 0, 0. This point is 10 with 0. Perpendicular bisector would be in the middle. It would be a line of x equals to 5. And it is greater than, so it means the portion which is right to this perpendicular bisector. Now we are going to combine these two. That would be our required locus, required points satisfying the above inequalities. Okay, now we have a circle with center 4, 2. This is 4, 5, 4, 3, 2, 1, 0. Okay, the center is 4, 2, and this is our line x is equals to 5. Right to this line and inside the circle, so this is our required locus. This is the required region which is supposed to be shaded. Let's shade it with a highlighter. Inside the circle and right to this perpendicular bisector. This is our required locus. Okay, now let's label this. We have already labeled it. It is arcane diagram. This is y, imaginary axis. This is x, our real axis. We have somewhere 6, 7, 8, 9, 10. Somewhere we have 10, 0. And this is a perpendicular sector of this. Okay, now this level is complete. So this is the required locus. Question number 5, B part, find the greatest value of the argument z. Argument z, that is angle measured from origin for this points in the region. In the shaded region, when it is connected with O, what would be the greatest possible argument? Now we have to find the, if we have to find the least argument, then that will be the least argument, as we have to find greatest argument. So greatest argument would be somewhere over here if it is touching that intersection line. So this is our required angle, greatest argument. So let's find out this angle. This angle, we have to find this angle, that much angle. Okay, so what is this point of intersection? We have to find this point of intersection in the first place. Okay, so it means we need that point of intersection, P coordinates. We know this is a circle and line x equals 5's point of intersection. So what is the equation of circle? X minus 4 whole square, because center is 4 and 2. Y minus 2 whole square equals to 3 square, which is 9. This is the equation of circle. Let's solve these two together simultaneously in order to find the coordinates of P. So I'm going to substitute x with 5. So y minus 2 whole square is equals to 9. So as a result, y minus 2 whole square is equals to 9 minus 1, 8. So y minus 2 square root plus and minus 8. So we are interested in the above point. So we are going to consider positive 8. So y is equals to 2 plus 8, or you can write 2 root 2. This is the value of y, and the value of x is obviously 5. So the coordinates of P are 5 and 2 plus 2 root 2. Okay, so now what would be the required argument? So tan of theta, y value is 2 plus 2 root 2 over 5. Take its inverse. So tan inverse 2 plus root 2, it is 0.7679. So 768, you can say, radians. So this is the greatest locus. This is the greatest argument of the given locus from the origin. Number 6. The equation of the curve is this implicit equation 2y squared plus 3xy plus x equals to x squared. We have to show that that would be its first derivative. Now this is an implicit equation 2y squared plus 3xy plus x equals to x squared. So let's differentiate it with respect to x. So 2y squared would be 4y dy over dx. Then we have 3xy. So let's consider 3x as, u, y is v. So 3x derivative would be 3y plus 3x, then derivative of y would be 3 dy over dx. Derivative of x is 1, derivative of x squared is 2x. Now we have to find dy over dx, so let's make dy over dx as a subject. So dy over dx, take common to 2 4y plus 3x and take rest of the things to right hand side. So 2x minus 3y minus 1. Now make dy over dx as a subject. So we have 2x minus 3y minus 1 over 4y plus 3x. Question number 6, B part, hence, that is using the previous information, show that the curve does not have a tangent that is parallel to the x-axis. Tangent parallel to x-axis means that the gradient would be 0. That is, if the gradient is 0, there is no such point. We don't have any point. It means we don't have tangent. Now, as it is given that the derivative is 0 because tangent is parallel to x-axis, so we will equate our derivative to 0. So 2x minus 3y minus 1 over 4y plus 3x is equals to 0. So do the cross multiplication. So we have 2x minus 3y minus 1 equals 0. So let's make x or y subject. I'm making x subject. So we have an equation or a relation in terms of x and y. Now substitute this back in the original expression, which was 2y squared plus 3xy plus x is equals to x squared. Let's substitute these values of x in it. So we have 2y squared plus 3y plus 1 over 2 plus 3y plus 1 over 2 is equals to 3y plus 1 over 2 whole square. So now let's simplify. So we have 2y square plus 9y square plus 3y over 2 plus 3y plus 1 over 2 is equals to 3y plus 1. It means we have to open it using the identity a square plus 2ab plus b over 4. Now we have 4 in the denominator. Let's multiply everything with 4. So 4 to the 8 y square, and on the left hand side when multiplied 4 cancel with 2, so 2 18 y square 6y again with 2 6y plus 2 is equals to 9y square plus 6y plus 1. Now we have fraction free expression. So take all the y's to the left hand side, to 8 plus 18 minus 9y squared, so that would be 17y squared, 17y squared, 6 plus 6, so that would be 12 plus 6, again 6, 2 minus 1, it would be plus 1 equal to 0. Now this is a quadratic equation in terms of y. Now we have to prove that this equation does not have any answer, no real root. Very easy. Yes, as it is a quadratic equation, so we can apply the natural root concept. Discriminant b square minus 4ac equals 0. Let's find out b square minus 4ac. If it is negative, that would show that line does not have any roots, any real roots in fact. 17 fours are 68. So as a result, we have a negative of 32, that is less than 0. It means no real roots for this quadratic expression. And in our discussion, as we are discussing that we don't have any tangent parallel to x-axis, so we can say that this shows no tangent parallel to x-axis. Question number 7. The diagonal was a curve and its minimum point is m, where x is equals to alpha. Show that this equation will satisfy this given information. Minimum point, it means we are going to find its first derivative at x equals to 1. So after taking the first derivative, we will substitute x is equals to alpha and equate the first derivative to 0. As a result, we will have this equation. This is our curve, so y equals to, let's find its derivative, dy over dx using the product rule. Derivative of x is 1, e raised to the power 2x. Then x as it is, derivative of e to x is e to x. The derivative of the power is 2 minus 5. Now it is given that at x is equals to alpha, we have minimum point. So let's replace x alpha and equate it to 0. So e to alpha plus 2 alpha e to alpha minus 5 equals to 0. So let's take e to alpha common. So e to alpha we take common, to e to alpha 1 plus 2 alpha minus 5 equals to 0. So let's take 5 on the right hand side. So e to alpha 1 plus 2 alpha is equals to 5. Now e to alpha 1 plus 2 alpha is equals to 5. So e to alpha equals to 5 over 1 plus 2 alpha. Now let's take the natural log of both sides. So we have ln e to alpha equals to natural log of right hand side 5 over 1 plus 2 alpha. So we have 2 alpha ln e, which is equals to 1. So right hand side is being mashed almost. Only 2 is missing, so ln is 1. So alpha equals to 1 over 2 of ln 5 over 1 plus 2 alpha. B part, verify by calculation that alpha lies between 0.4 and 0.5. To prove that, we will make an equation for that. We will make it to 0, convert it to 0. So let's do that. 1 over 2 natural log 5 over 2 plus 1 plus alpha. 1 plus 2 alpha minus alpha equals to 0. Now let's label it as f of alpha, make a function of it, an expression in which we are going to substitute the range of values. First of all, we will substitute 0.4. So f 0.4, f of 0.4, let's see whatever the value it is, then substitute f 0.5. The sign will differ. When we substitute 0.4, we have 0.110. When we substitute 0.5, we have minus 0.0418 as sign changes from negative to positive. This shows 1 root lies between 0.4 and 0.5. Question number 7, C part. Use an iterative formula based on the equation in part A to determine alpha correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Okay, question number 7, C part. Iterative formula. Question number 7, C part. In this question, we are not given with the initial value, but we do know that the range in which the value of alpha will fall is between 0.4 and 0.5. So we can consider any value between 0.4 and 0.5. We can take 0.41 to 0.49, but not exactly 0.4 and 0.5. So I'm taking the average of 0.4 and 0.5, which is 0.45 as initial value. Okay, now how we are going to do that with the help of calculator? Let's see the steps in the calculator. First of all, we are going to substitute the value, initial value, which I have just considered 0.45, and press equal to sign. Now this value is being stored in the answer space. So now we are going to use this value, this expression in the calculator, like 0.5, 1 over 2, 0.5 times natural log, then like stars, it's fraction key, numerator is 5, down 1 plus 2 times of. Now here is the interesting thing. For alpha, I will use answer key, answer, right arrow, bracket close. Now when I press first equal, I will get the first iteration, 0.4838. But this value is not being rounded off to, 4 decimal place. So shift mod, we have fix 6 and 4. Now all the answers will be automatically rounded off for you as well. So now we press one more time, we get the next iteration A3, 0.4663, one more equal 0.74753, then 4707, 4730, and so on, 0.4718. You can calculate two more iterations if you want to. As we see that after 2 decimal places, the answer is being repeated, so our answer is 0.47. That's it. Question number 8, A part, express this trigonometric ratio in R form, where R is positive, angle alpha is between 0 and pi over 2, and the value of R is exact value, that is in the root form, and the value of alpha is correct to 3 decimal places. Question number 8, A part, we have to convert this into R form, 3 sine x 2 root of 2 cos of a, that is x plus pi over 4, pi over 4, that is pi over 4 is equals to r sine of x plus alpha. This is what is required, and given that r is positive and alpha is in between 0 and pi over 2. So let's expand the. First of all, let's simplify left hand side. So 3 sine a plus 2 root of 2 cos a plus b formula, cos a cos b minus sine a and sine b. This is equals to r sine x plus. Okay, we know that cos pi over 4 is 1 over root 2. we know that cos pi over 4 and sin pi over 4 both are equals to 1 over root 2. So let's expand it along with the expansion as well. So 2 multiplied by 2, so it would become 2 cos of x minus 2 sine of x is equals to r sine x plus alpha. Now on the left hand side we have two sines, so let's to combine them together. So we have over here sine x and 2 cos x. Now left hand side is being fully simplified. So let's expand the right hand side now. Sine a plus b formula. So we have r sine a, sine a cos b plus r times cos a sine b. Now let's compare the coefficients of sine x and sine x, cos x, cos x. So as a result, we have r cos alpha equals to 1 and r sine alpha equals to 2. So for here we can find cos alpha equals to 1 over r, sine alpha equals to 2 over r, where we can apply the identity sine square alpha cos square alpha equals to 1, squaring both sides, so we have 4r squared and 1 over r square equals to 1. So r is equals to root of 5. Now we have the value of r, so we can write the value of sine alpha. Sine alpha would be then 2 over root 5, or you can write cos alpha. Cos alpha would be 1 over root 5, or you can also say tan alpha equals to 2 over 1. You can take the inverse of any one of these, sine alpha, cos alpha, or tan alpha. The answer with alpha would be the same, 1.103 to 3 decimal place. So it means our required expression, which was 3 sine x plus 2 root of 2 cos x plus pi over 4, becomes root 5 sine of x plus 1.107. This is our required R form. Question number 8, B part. We have an equation which we have to solve, but before that, what we have done so far, we have done this R form, 3 sine x, 2 root of x, 2 root of 2 in fact, 2 root of 2 and cos x plus pi 4 is equals to root of 5 sine x plus 1.107. Okay, now what is in the B part? In the B part, we have to solve an equation 6 sine of theta over 2. The angle is different, it doesn't matter, we will replace it with some variable. But here we have 4 root of 2 cos theta over 2 plus pi over 4 is equals to 3. Now our left hand side is not matching with our B parts left hand side, so we are going to divide this whole equation by 2 so that it matches with our R form. Now this is exactly our R form, the only difference is now the angle. The angle is x, here it is theta over 2, it doesn't matter. So it means left hand side can be replaced with our R form by replacing x with theta over 2. The rest of the things are fine. So theta over 2 plus 1.107 equals to 3 over 2. And now we are going to solve this equation. So sine of theta plus 1.107 equals to 3 over 2 root 5. Okay, so we have done the first part. So before we start our question, let's see what is the range of this question. The range for this question given is minus 4 pi to 4 pi for theta, but we have theta over 2, so it would be minus 2 pi to 2 pi, and then we have 1.107, so let's add 1.107 to both left hand side and to right hand side. Let's see what is the value. So we have 2 times pi plus 1.107 is equals to 7.39, 7.37 it is 7.39. Okay, let's find the lower limit. Theta over to minus, it's minus. So it's minus 5.17, minus 5.17, minus 5.17. So it means this is the range within which we have to find all the possible angles. Okay, minus 5.17, 7.31. Okay, now let's start. Now, first of all, we do all the steps which we usually do in trigonometric solution. First thing is identify the quadrant. It will be in first and second because sign is positive. Then after that, we find the basic angle 3 over 2 root 5. So the basic angle is 0.7353. This is the second step. First step, second step, then the third step. In the third step, we just draw this basic angle in the first and second quadrant and find all the angles in the first positive revolution. That would be theta over 2, 1.107. The angles would be 0.7353 and 2.406. Now we have to see whether we can go beyond these first range. So let's start from the very first angle, add 2 pi in it. If our angle falls within this range, then we will accept, otherwise we will reject it. So after adding this 0.7353 plus 2 pi, we get 7.018, so we will accept. Now similarly, if we add 2 pi in it, it is outside the range, so we will not accept it. Now let's go beyond. Subtract 2 pi from here, 2.406 minus 2 pi, so minus 3.877, it is inside the range. Then subtract 2 pi from here, so we have minus 5.548, it is again outside the range. We will not accept this. So it means we are going to go further for these 4 values. It means now we are going to do further calculation for these 4 highlighted values. How we are going to do the working? We will add 1, we will subtract 1.107 and then multiply with 2. So as a result, the answers are minus 9.97, 0.744, 2.60, 4.60, and 11.8. These are the 4 possible values of theta. Question number 9. Vectors relative to the origin, the position vectors of points A, B, and C are given. Show that OABC is a rectangle where O is the origin, obviously. Now we have to prove. Question number 9 means paper. First of all, we have to prove that it is a rectangle. So let's label it OABC in either clockwise or in anti-clockwise. The main objective is to identify or to work on the opposite vectors. So here opposite vectors are OA and CB, and opposite vectors are OC and AB. So let's find out these vectors at the first place. So we know already what is OC. OC is equals to 3, 4, minus 7. So I'm going to write it in column vector format. OA is again 5 minus 2j. So it is 5 minus 2 and 1. Let's find out the other two vectors, AB and CB. So for AB, I will convert it into position vectors OB minus OA. So that would be OB is 8, 2 minus 6, and OA is 5 minus 2 and 1. Subtract these two. 8 minus 5 is 3, minus 2 minus 2 is 4, and it is minus 7. 3, 4, minus 7. It is AB vector. Similarly, let's find CB vector. CB vector. So CB vector would be OB minus OC. So OB is same 8, 2 minus 6, and OC minus OC 3, 4, and minus 7. So after subtracting, we have 5 minus 2 and 5 minus 2 and 1. Okay, now we have all the possible vectors, all the vectors of the sides OA, AB, CB, and OC. Okay, we have proved that opposite sides are parallel because opposite side vectors are exactly same. So this shows that opposite sides are parallel and equal. So this concludes that OABC is a parallelogram. So we don't have to find the lengths as the vectors are exactly same, but you can also find it. Next we have to prove that the adjacent angles are 90 degree. For that method, we have to find dot product of the adjacent vectors. OC is adjacent to OA. It means their dot product should be 0. Okay, let me change the color for that method. Now OA dot OC, OA is 5 minus 2 and 1 dot 3, 4 minus 7. So it is 15 minus 8 minus 7 is equal to 0. This means OA and AC are perpendicular. Then we pick up the other two, CB and AB. CB and AB, they are also adjacent sides. CB and AB, this is at angle B. So CB vector is 5 minus 2 and 1. And AB is 3, 4 minus 7. Again, obviously the answer is the same. 15 minus 8 minus 7 is equal to 0. And their opposite sides are parallel and equal because the magnitudes and vectors both are equal. But this shows that OABC is a rectangle. Question number 9, B part, we have to find the angle between the diagonals of the rectangle OABC. Now we have to find the angle between the diagonals. Diagonals are OB and OC. So let's find those vectors. We already have OB vector. The OB vector is equals to AC vector. Let's find the angle between diagonals. So let's find the AC vector. AC vector would be OC minus OA. So OC is 3, 4, minus 7, and OA is 5, minus 2, and 1. So we have minus 2, 6, and minus 8. This is AC. And OB is already given 8, 2, minus 6. So let's find the dot product between these triangles. So AC dot OB would be minus 2, 6, minus 8 dot 8, 2, minus 6, minus 16, plus 12, minus plus 48. So solve this, we have minus 4, that would be 44. This is the dot product. Let's find their magnitudes, or AC magnitude and OB magnitudes. So AC magnitude would be x square, y square, z square. So it is 4, 36, and 64. 40 plus this, so it is 104. Then OB magnitude. OB magnitude is 64 plus 4 plus 36 is equals to 104. By the way, we can also prove diagonals equality in order to prove that it is a rectangle. And in the previous part, we have used the method to find the angles between the adjacent side 90-degree angle. Instead of that, if we prove that the diagonals are equal in length, by doing so, we can also prove that the diagonal that it is a rectangle. Anyways, let's find the angle. The angle between these two diagonals would be cos of theta AC dot OB dot of the diagonals and over the magnitudes. So let's substitute the values. AC dot OB, it is 44, and 104, 104, take its cos inverse, we have 65 degree. So this is the angle between the two diagonals. 8, 2 minus 6, but we don't have 8, 2 minus 6. So let's find the dot product between these triangles. So AC dot OB would be minus 2, 6 minus 8 dot 8, 2 minus 6 minus 16 plus 12 minus plus 48. So solve this, we have minus 4, that would be 44. This is the dot product. Let's find their magnitudes, or AC magnitude and OB magnitudes. So AC magnitude would be x square, y square, z square. So it is 4, 36, and 64. 40 plus this, so it is 104. Then magnitude. OB magnitude is 64 plus 4 plus 36 is equals to 104. By the way, we can also prove diagonals equality in order to prove that it is a rectangle. And in the previous part, we have used the method to find the angles between the adjacent side 90-degree angle. Instead of that, if we prove that the diagonals are equal in length, by doing so, we can also prove that the diagonal that it is a rectangle. Anyways, let's find the angle. The angle between these two diagonals would be cos of theta AC dot OB dot of the diagonals and over the magnitudes. So let's substitute the values. AC dot OB, it is 44, and 104, 104, take its cos inverse, we have 65 degree. So this is the angle between the two diagonals. Question number 10. F of x, where a is a positive, expressed in partial fraction. It is a proper fraction because in the numerator we have just constant, in the denominator we have x cubed, and all these are linear factors. So let's do its partial fraction. It means that expression can be written as 36 a squared, which is given expression, 2a plus x, 2a minus x, and 5a minus 2x is equals to a over the first factor, because it is a linear. All these are linear factors, which means we will have constants in the numerators. First factor, this is second factor, and that would be the third factor. This is our equation number 1. This is what is required. So what is the second step? We are going to multiply left hand side's denominator throughout. So as a result, we will have a fraction free expression. So we have 2a minus x, 5a minus 2x plus b times of 2a plus x, 5a minus 2x plus c times of 2a plus x, 2a minus x. Now we do rest of the procedure, rest of the working in b equation. So first of all, we are going to find a. For that, we will equate the denominator of a equal to 0. So we are going to substitute x equals to minus 2 over a. By doing so, we will get the value of a. x equals to minus 2 over a. So 36a square minus 2a. So 2a minus 2a, that would be 4a. 5a minus 2a, that would be 9a. And rest of the terms would be 0. So as a result, we have 36a square on the left, 36a square on the right. So a equals to 1. Okay, so now let's work on the b. For b, we will equate this expression, this whole expression, to 0. So we will substitute x equals to 2a. By doing so, we will get the value of b. Okay, let's see. 36a squared, the first expression would be 0. For b, it would be 2a plus 2a, that would be 4a. 5a minus 2a, that would be 5a minus 2, that would be a, just a. So 36a square plus 4 is equals to 4a square b. So b is equals to 9. Now let's do the working for c. For c, we will equate 5a minus 2x equal to 0. So we get x equals to 5a over 2. So 5a over 2. We will replace 5a over 2 in equation number 2. So 36a square, first expression 0, second 0. The third one would be 2a plus 5a over 2. 2a plus 5a over 2 and 2a minus 5a over 2. Let's simplify this and then divide 36a squared to simplify answer. The answer for C is minus 16. So finally, our partial fraction would be, that is our expression, f of x becomes a is 1, so 1 over 2a plus x. B is 9, so 9 over 2a minus x. And c is 16, so minus 16 over 5a minus 2x. This is our required partial fraction. Question number 10, B part. Hence, find the values of this partial fraction integration. Limits minus 8a. Give your answer in the form of p and q plus r, l, and s. Where p and r are integers and q and s are prime numbers. The numbers inside the logs are prime numbers. The coefficients may be some numbers which may not be prime. In fact, they are not prime. Anyways, so it means we are going to use the results of part. Okay, now B bar. First of all, let's write down the expression f of x, which we have just converted into partial fraction. 1 over 2a plus x plus 9 over 2a minus x, then 16 over, so let's write 16 outside, 16 over 5a minus 2x. We are supposed to do the integration of left hand side as well as of right hand side. It means integration of each and every term on the right hand side. Integration and integration. Okay, now if we look at the question carefully, now we have first fraction is all set because we have derivative of denominator in the numerator, so we can integrate it directly. So it's ready, it's already set. 2a plus x dx. But the first second expression, it should be negative, so I'm writing 9 with the negative outside and minus 1 in the numerator. So now we have a derivative of denominator in the numerator for the second term as well. But for the third one, the derivative is minus 2 and we have 16, something extra. Let's take 8 outside so that we have just minus 2 in the numerator. So now again, our task is achieved, our target is accomplished, that is derivative of the denominator is in the numerator. Okay, now let's do the integration in one go for all the terms. First one would be log of the denominator. Second was 9 times log of the denominator. And the third one is also 8 times log of the denominator. And now as we have done the integration, so we are supposed to write c over here. But what I'm going to do, I'm going to write down left hand side and place the limits. So on the right hand side, we also place the limits minus a and a. So upper limit is a, lower limit is minus a. So let's substitute the values carefully. Okay, so log of a, 2a plus a, that would be 3a, minus log of 2a minus a, that would be a, 8 ln 5a minus 2a, that would be 3a. This whole thing is the upper limit. Then the lower limit minus a is the lower limit. So ln 2a minus a, ln a plus minus minus plus, so minus minus plus, so it's negative, solid negative, so it's minus 9 ln 3a, then plus 8 ln 5 plus 2 7a. Now we have substituted successfully the limits. Now let's expand this and then see what will happen. Okay, now ln 3a minus ln a, 8 ln 3a, so minus ln a plus 9 ln 3a and minus 8 ln 7a. Now, as in the question, it is given that there is no a, everything is integers or numbers, prime factors. Inside the logs we have prime numbers, outside we have numbers, so there is no room for a. So let's expand and try to eliminate a's. Now let's apply the loss, law ln 3 ln a minus 9 ln a, it is already one term, so 8 ln 3, 8 ln a ln a plus 9 ln 3, 9 ln a minus 8 ln 7 minus 8 ln a. Now let's see how many things we can cancel out. Okay, minus ln a. So let me choose some other color, maybe yellow. Okay, now this ln a, 9 ln a will be cancelled out with 9 ln a, ln a with this ln a, and 8 ln a. Do we have another 8 ln a? 8 ln a. Yes, 8 ln a cancel out with this 8 ln a. So all the ln a's are now being cancelled out. So let's see how many ln 3's we have. ln 3 is ln 3, ln 3, and ln 3. So we can add their coefficients. So that would be 18 ln 3. And then we have 7 ln 7. So ln 7's are 1 ln 7, only 1 ln 7, so minus 8 ln 7. So the final answer is 18 ln 3 minus 8 ln 7. Question number 11. The variables y and theta satisfy the differential equation 1 plus y, 1 plus cos 2 theta, dy deta, e raised to power 3y, where y is theta, theta is power 4. Solve the differential equation after solving it for tan theta when y is 1. Okay, this is the question. Okay, let's write on the differential equation which is given in the question. 1 plus y, 1 plus cos of 2 theta, dy over d theta, e 3y. All the d's should be in the numerator and the variables should be separated. So we are going to do that. So 1 plus y, e raised to power 3y, I'm going to take it on the left hand side, and with dy, and d theta on the right hand side along with this, but this is going to be in the denominator. Okay, no problem. It is 1 over 1 plus cos 2 theta. Now the variables are being separated successfully. Okay, now we can do the integration on the left hand side easily, but not on the right hand side. So let's apply some formula so that we can eliminate this one. We know that cos of 2a equals to 2 cos square a minus 1. Let's apply this formula on the right hand side. Left hand side, it's the same, no change. because it is already set for integration. On the right hand side, I'm replacing cos theta with 2 cos squared theta minus 1. Now 1 cancel out with 1 and we are left with 2 over cos squared theta. So we have 1 plus y e raised to power minus 3y dy equals to 1 over 2 cos squared theta d theta. Now we also know this relation that 1 over cos theta is equals to secant theta. So this cos square theta can be written as secant square theta. So this would be 1 over 2 secant square theta. Now all the variables are being separated and ready for integration. Now before we do integration, this 2 is on the right hand side may be difficult to perform further calculations. So we avoid fractions. So multiply left hand side and right hand side by 2. So we have 2 1 plus y e raised to power minus 3y dy, and this is equals to secant squared theta d theta. Okay, now we are ready to do the integration, but again, if we do this step, this is optional one, that if you look at the question carefully on the left hand side, we have to apply integration by parts. When we do integration by parts, the integration of e raised to power minus 3y. So this is just, we know that the integration of e3y would be e3y over 3. We will have 3 in the denominator. And as it is doing, we are doing integration by parts. So in the second layer, we will again integrate this. We will have another 3. So we will have 9 in the denominator. So if you want to avoid these denominators at the first place, so multiply left hand side and right hand side by 9. So on the right hand side, left hand side, I have 18, and on the right hand side, I have just 9 secant square theta. The, this step is optional. This is not compulsory. This step is in order to avoid the fractions. Okay, now let's do the integration. We know the integration. Integration by parts. So which function is the first function? First function would be this one. This is algebraic, and this is exponential. You know the Pillet rule. If we have log, you know the Leate rule. Leate rule. If we have log, then it is the first function. If it is algebraic, then it is the first function. So this is your first function, and this is your second function. Okay, now let's write down the formula for integration by parts. If you have two functions, first function, second function. First function as it is, integration of second minus integration of second times derivative of first. After that, we will integrate this whole thing again with respect to x in the next step. That's why it is known as integration by parts. Now here in this question, first function is 1 plus y and second function is exponential. Okay, now let's start it. Okay, first function as it is, integration of second function e minus 3 pi over 3 minus integration of second again into derivative of first, which is 1, and then it is dx. This is integration by part. That's it. Then we know that the integration of secant square theta is tan theta. So it is tan of theta plus c. Now let's simplify it. Now 18 1 plus y e raised to power minus 3y over minus 3. Now we are going to integrate this whole thing with that would be minus 1 over 3 just outside. This is the coefficient. Integration of minus 3y is minus 3y over minus 3 is equals to 9 tan theta plus c. Now let's multiply this 18 on the left hand side. So we have 18 with this with a negative of 6. So we have minus 6. 1 plus y e raised to power minus 3y. 1, 2, 3, 3 negatives. So we have minus 2 e raised to power minus 3y equals to 9 tan theta plus c. Now we know that when y is 0, theta is power 4. Substitute y 0 and theta equals to pi over 4. So as a result, we get minus 6, y is 0, y is 0, e raised to power 0 is also 1, e raised to power 0 is 1, and tan pi over 4 is also 1 plus c. So minus 8 minus 9, c is equals to minus 17. So our equation becomes minus 6 1 plus y e raised to power minus 3y minus 2 e raised to power minus 3y 9 tan theta is equals to minus 17 plus 17 minus 17. So we have the last part, find the value of tan theta when y equals to 1. Now I'll place y equals to 1 in this expression. So it is 1 plus 1 2 e raised to power minus 3y minus 2 y is 1, so y is minus 3 minus 2 minus 3 sine theta minus 17. Now let's make tan theta as subject. So it is 6 to 12, 12 is a 14, so it is 17 minus 14 e minus 3. So tan theta would be 17 minus 14 e power minus 3 over 9. So this is our required value of tan theta when y equals to 1.